The last part of this church exercise is to do an overall water budget, or to look at the different volumes of runoff, infiltration, and evapotranspiration. And I'm going to actually do this I'm going to jump to a spreadsheet I set up for this. And there are tools out there. The EPA Stormwater Calculator does something like this, and they'll show you your results in a pie chart, and you can choose different best management practices. So there are several different ways to get at it, but I'm going to just go through here and I'll show you a spreadsheet to kind of show you what we're talking about, how the basics of it work. So I have this set up ahead of time here, and what I'm going to say is that pre-development I have 60% woods, 40% meadow, and then I want to know for these different areas how much is runoff, infiltration, or evapotranspiration. So I'm looking at my chart down here, and I'm going to go with undisturbed woods for the pre-development woods part. So it says down here the runoff is 5%, the infiltration is 45%, and the evapotranspiration is 50% for that. Oops, I missed the column there. Evapotranspiration is 50% for that. And then for the meadow, undisturbed meadow, runoff is 7%. That's pretty low. The infiltration is 45%, and the evapotranspiration is 48%. So overall, so I have this area times the runoff, so that's the area weighted runoff. So overall, I have 6% runoff, 45% infiltration, 49% area weight. And I just have these here as a check to make sure everything adds up to 1. And then post-development, I have the church area, the building, and then the parking lot. And we've calculated before the building ends up being 6% of the total area. So that comes out of this 60%. So 54% is the lawns and stuff around the church, and 40% is the parking lot. So if I go down to my chart here, I say for the church area, I'll say undisturbed lawn for that. Maybe there's a better number I could get for that. So that's 15% runoff. The 40% infiltration, and 45% evapotranspiration. The building can be considered as impermeable. It's just going to run off. Now, I can do something with the water coming out of the gutter. I can run that over different things, and that might be part of my best management practices I do. I can run that into an area so it will infiltrate. But let's just do it like we're taking it out of the gutter and then we're sending it maybe into a storm sewer across the parking lot. We're letting it run off. So I'm going to go with impermeable surface. I'm going to say we have 95% runoff, 0% infiltration, and 5% evapotranspiration. And I'll do the same thing for the parking lot. So I'll do 95%, 0%, and 5%. Alright, so we've gone from 6% runoff pre-development to 52% runoff post-development. That's not good. What can we do about it? Well, let's look at a couple things we can do. So for this next step, I'll start out with the same numbers here. So 15, 40, 45, 95, 0, 5, 95, 0, 5. So what can I do? For the parking, let's take half of that and let's make it everybody's favorite permeable pavement. It has its limitations, but it can be done. We have some on campus at Messiah. So I'm going to take half of my parking and convert it to permeable pavement. So the original parking is now 20% of the area. Permeable pavement is 20% of the area. And then, according to my table here, permeable pavement, runoff 15 to 50%. Let's say we have amazing permeable pavement. It's only 15% runoff and 70% infiltration. So that leaves 15% evapotranspiration. And our building, let's make that a green roof. So we'll have, and maybe we can make 2/3 of it a green roof. So 0.04, and then now this is 0.02. It's a tiny bit of the area. It's not going to make that much difference. But let's say we can do it. So we have 40% runoff. That's still quite a bit. 0% infiltration, but we do get 60% evapotranspiration. So it makes a little bit of difference. And now we're down to 34% runoff compared to 52%. So I had these conditional formatted. Lower is better. Now this table here, this is a little bit confusing, but I put these numbers in there. This is if you look at the table, so this will take the runoff from another area, and if I put it through bioretention shallow media depth, I can get 5 to 30% of that runoff that's coming from another area to infiltrate, and 15 to 20% to evapotranspirate. So if I wanted to put that in my spreadsheet, it's a little more complicated. I have to take like of this parking lot runoff, that's 40% of the total water balance. If I put that through here, I can get, a 1/3 to a 1/2 of it to infiltrate and go from there. But this is the idea, is that you start putting in these best management practices, and then we can get more infiltration and evapotranspiration and less runoff. And we saw a couple other ways to do this. We saw in the Pennsylvania spreadsheet, you can get some credit for those. And like I said, the tools for doing this over a water balance are in several different places. This was actually from an old North Carolina, had spreadsheets that would do this for you. So these are the tables for that, and you can put those numbers in there. Anyway, that can be an important part of our stormwater management, is to do the overall water balance or water budget for that. All right, we'll move on.